Hello and welcome to Astronomy Daily. I'm Anna, bringing you the latest developments in space and astronomy news. Today we have a packed episode covering a wide range of fascinating stories from across the cosmos. We'll check in with NASA astronauts Butch Wilmore and Suni Williams as they recover from what was meant to be an 8-day mission, but turned into a 9-month stay aboard the International Space Station. I'll also tell you about a truly mysterious star that pulses every 44 minutes in both radio waves and X-rays, leaving scientists puzzled about its true nature. Then we'll explore China's ambitious Tianwen 2 mission that just launched to collect samples from a living fossil asteroid. We'll round up this week's busy launch schedule from around the world and end with some slightly unsettling news about Earth's long-term orbital stability and a potential cosmic fate that thankfully remains extremely unlikely. Stay with me for all this and more on today's Astronomy Daily. Let's kick off with a story I'm sure most folks thought was done and dusted. Turns out there's an epilogue. NASA astronauts Butch Wilmore and Suni Williams are making steady progress in their recovery after returning to Earth following what became an unexpectedly extended mission in space. What was originally planned as an 8-day test flight aboard Boeing's Starliner capsule turned into a 9-month stay on the International Space Station when propulsion system issues forced NASA to bring the capsule back without its crew. The astronauts, now back on solid ground since March, have been undergoing intensive physical therapy as part of the standard 45-day reconditioning period for long-duration space travelers. Wilmore, who is 62, described the challenging readjustment to Earth's gravity in a recent interview, noting that gravity stinks for a period as astronauts deal with balance issues and muscle weakness after extended time in microgravity. Williams, 59, shared that some of her post-spaceflight side effects were slower to resolve. She experienced significant fatigue during the later stages of recovery as dozens of muscles re-engaged after months of disuse. The veteran astronaut couldn't maintain her preferred early morning routine until recently, when she happily reported, "Then I'm up at 4 a.m, and I'm like, aha, I'm back." For Wilmore, the return to Earth reintroduced him to some familiar discomfort. He had experienced neck pain before his mission that completely disappeared in the weightlessness of space. Remarkably, he felt that same pain return while still in the Starliner capsule bobbing in the ocean, even before extraction teams had reached them. The human body, having evolved over millions of years in Earth's gravity, undergoes significant changes during spaceflight. Without gravity's constant pull, astronauts experience muscle atrophy, cardiovascular shifts, and other physical changes that require dedicated rehabilitation upon return. While recovering physically, both astronauts have been ramping up their work schedules with Boeing's Starliner program, NASA's space station operations in Houston, and agency researchers. Williams described the past months as a bit of a whirlwind as they balance their recovery with professional obligations. Meanwhile, NASA faces important decisions regarding Boeing's troubled Starliner program. Williams has publicly advocated for requiring Boeing to fly Starliner uncrewed before putting humans aboard again, calling it the logical thing to do, and drawing comparisons to SpaceX and Russian spacecraft that underwent similar safety validation. NASA officials have indicated that additional testing planned throughout the summer will determine whether Starliner can carry humans on its next flight. As you know, I love a good mystery here on Astronomy Daily, and here's today's. Scientists have discovered a truly puzzling cosmic object that's breaking all the rules of what we thought we knew about stars. It's called ASCAP J1832, and what makes it so extraordinary is its unusual pulsing behavior. It sends out bursts of energy every 44 minutes with clockwork precision. ASCAP J1832 belongs to a rare category known as long-period radio transients, which were only first discovered in 2022. Unlike typical pulsars that flash multiple times per second, these objects pulse much more slowly. But what truly sets ASCAP J1832 apart is that it's the first of its kind to emit both radio waves and X-rays on the exact same 44-minute cycle. This groundbreaking discovery came through the combined observations of NASA's powerful Chandra X-ray Observatory and Australia's ASCAP radio telescope. When scientists created composite images using data from these telescopes, along with infrared information from NASA's Spitzer Space Telescope, they revealed a vivid portrait of this stellar enigma. The mystery deepened when researchers noticed that ASCAP J1832's emissions faded dramatically over a 6-month period in both radio and X-ray wavelengths. This combination of short-term pulses with long-term changes makes it unlike anything previously observed in our Milky Way galaxy. Astronomers are struggling to explain what could cause such behavior. ASCAP J1832 doesn't fit neatly into any known category of stellar objects. It's unlikely to be a typical pulsar or a neutron star pulling material from a companion star because the intensities of its radio and X-ray signals don't match what we'd expect. Some of its properties suggest it could be an extremely magnetic neutron star, what astronomers call a magnetar, that's over 500,000 years old. However, other features like its bright and variable radio emission are difficult to explain for such an aged magnetar. Initially, scientists thought ASCAP J1832 might be associated with a nearby supernova remnant, as these exploded stars often contain neutron stars. However, further investigation suggested this proximity is likely just coincidence. The research team is now considering more exotic possibilities, including that it might be a white dwarf star with a companion. If true, it would require the strongest magnetic field ever recorded for a white dwarf in our galaxy. For now, ASCAP J1832 remains a one-of-a-kind cosmic mystery that could potentially represent an entirely new class of astronomical objects. Next up today, China has taken a major step forward in its space exploration program with the successful launch of the Tianwen 2 probe, the country's first-ever asteroid sample return mission. A Long March 3B rocket carrying the spacecraft blasted off from the Xichang launch site in southwestern Sichuan province early Thursday morning local time. About 18 minutes after liftoff, the probe was successfully inserted into its transfer orbit from Earth to asteroid 2016 HO3, also known by its official name, Kamo Oalawa. The China National Space Administration confirmed that the spacecraft deployed its solar panels as planned and declared the launch a complete success. This ambitious mission targets what scientists describe as a living fossil asteroid, measuring between 40 to 100 meters in diameter. Kamo Oalawa orbits relatively close to Earth and consists of ancient materials that could provide crucial insights into the formation of our early solar system. What makes Tianwen 2 particularly interesting is its complex mission profile. The spacecraft will spend approximately 30 months on its journey to and from the asteroid. Once it arrives, it will perform 2 different types of sample collection. First, the probe will touch down on the asteroid's surface to collect material using a drill. Then it will perform a touch-and-go sample collection, similar to NASA's OSIRIS-REx mission. In total, the spacecraft aims to collect about 1,000 grams of asteroid material. But the mission doesn't end there. After delivering the precious samples back to Earth, the main spacecraft will continue its journey through space. Using Earth's gravity as a slingshot, Tianwen 2 will be redirected toward a fascinating object called 311P/Pan-STARRS in the main asteroid belt between Mars and Jupiter. This second target is particularly intriguing to scientists because it exhibits characteristics of both asteroids and comets, making it a valuable subject for further investigation. The entire mission is expected to last approximately a decade. This latest achievement represents another significant milestone in China's rapidly advancing space program, which President Xi Jinping has described as the country's space dream. In recent years, China has established its own space station, landed rovers on Mars and the Moon, and is planning crewed lunar missions later this decade. It's been an exceptionally busy week in the rocket launch sector, with multiple missions taking off from launch pads around the world. SpaceX continues its rapid-fire cadence with several Starlink deployments already underway or scheduled in the coming days. On Wednesday, a Falcon 9 rocket thundered off Launch Complex 39A at Kennedy Space Center in Florida, carrying 27 Starlink V2 mini-satellites into low Earth orbit. Despite only a 60% chance of favorable weather, SpaceX managed to launch right at the beginning of their 4-hour window. The mission used Booster B-1080, which incredibly was flying for its 19th time, a remarkable testament to SpaceX's reusability program. Looking ahead, SpaceX has at least 2 more launches planned this week. On Friday, they're scheduled to launch the GPS-3SV08 mission for the U.S. Space Force from Cape Canaveral. This mission was actually originally assigned to ULA's Vulcan rocket before being reassigned to Falcon 9. Then, just 1 minute after the GPS launch window opens in Florida, another Falcon 9 is set to lift off from Vandenberg Space Force Base in California with yet another batch of Starlink satellites. Then early next week, SpaceX has scheduled Starlink Group 12th 9 to launch from Cape Canaveral, continuing their rapid deployment of their internet constellation. China has also been active beyond the Tianwen 2 mission we just discussed. The China Aerospace Science and Technology Corporation launched another mission on Thursday using a Changjiang 2D rocket from the Jiuquan Satellite Launch Center. The payload for this particular flight remains undisclosed, marking the 5th Changjiang 2D mission of 2025 and the 99th overall for this reliable Chinese launch vehicle. Meanwhile, Blue Origin is preparing for its 4th New Shepard mission of the year, scheduled for Saturday morning. This suborbital flight will lift off from their West Texas facility, carrying 6 passengers just above the Kármán line, where they'll experience a brief period of weightlessness before the capsule returns to Earth. This will be New Shepard's 12th crewed flight overall, continuing to advance private human spaceflight capabilities. Rocket Lab had planned a launch of their Electron rocket from New Zealand this week, but they've postponed until June 3rd due to additional checks needed and unfavorable weather conditions at the launch site. Finally today, please don't let this news keep you up at night, but I've got some potentially unsettling news about Earth's cosmic future. New computer simulations have revealed a previously underestimated risk to our planet's orbit. While it's not exactly time to panic, the findings are certainly intriguing. Astronomers Nathan Kaib from the Planetary Science Institute and Sean Raymond from the University of Bordeaux have discovered that passing stars could disrupt our solar system in ways we hadn't fully appreciated before. Their research shows that these stellar flybys could exacerbate an existing vulnerability in our planetary neighborhood. It turns out Mercury is the potential troublemaker here. The innermost planet already has a fairly elliptical orbit, and Jupiter's gravitational influence can make that orbit even more oval-shaped over time. What these new simulations reveal is that when you add the gravitational effects of passing stars, Mercury's orbit can become dramatically more eccentric. Once Mercury goes haywire, chaos can unfold. In typical scenarios, Mercury might collide with Venus or plunge into the Sun, but the resulting orbital disruption can then trigger a cascade of planetary instability. In some simulations, Venus or Mars crash into Earth, or Earth itself collides with the Sun. Another possibility is that Venus and Mars could gravitationally slingshot Earth toward Jupiter, which could then eject our planet from the solar system entirely. Before you start planning for cosmic doom, the researchers emphasize that the probability of such catastrophes is extremely low. Over the next 5 billion years, roughly the remaining lifespan of our sun, there's only a 0.2% chance of Earth meeting such a fate. However, that's significantly higher than previous studies had calculated, as they didn't fully account for the cumulative effects of passing stars. The most dangerous scenarios involve stars that pass particularly close to our solar system, within 100 times Earth's distance from the Sun, or stars that move relatively slowly, extending their gravitational influence. There's about a 5% chance of such a close stellar encounter over the next 5 billion years. Interestingly, the simulations suggest that distant Pluto faces even greater risks. Despite its protective orbital resonance with Neptune, passing stars could disrupt this arrangement, giving Pluto a 4% chance of being ejected or colliding with a planet over the same time frame, 20 times the risk Earth faces. While these cosmic timescales far exceed human planning horizons, they provide fascinating insights into the long-term dynamics of our solar system and remind us that even in space, nothing lasts forever. And with that cheery news, I'll conclude our cosmic journey for today on Astronomy Daily. From astronauts readjusting to Earth's gravity after an extended space mission, to mysterious pulsing stars, asteroid sample missions, and even the potential long-term fate of our planet, the universe continues to surprise and fascinate us. I'm Anna, and I hope these stories have sparked your curiosity about the vast cosmos we're all a part of. The beauty of astronomy is that there's always something new to discover. Whether it's a strange stellar object pulsing every 44 minutes, or understanding how our own planet might navigate cosmic challenges billions of years from now. If you'd like to stay connected with the latest developments in space and astronomy, please visit our website at astronomydaily.io, where you can sign up for our free daily newsletter. Our site features a constantly updating newsfeed with all the latest space and astronomy news as it happens. Don't forget to subscribe to this podcast on Apple Podcasts, Spotify, YouTube, or wherever you get your podcasts so you never miss an episode. Your support helps us continue bringing these fascinating stories to you, and if you could, a review would be greatly appreciated too. Thank you for listening to Astronomy Daily. Until next time, keep looking up.